STE. This is your digitized instructional materials in Science 8. Okay, the Unit 1, Force, Motion, and Energy. So here's the objectives. Investigate the relationship between the amount of force applied and mass of the object to the amount of change in object motions. Infer that the body exerts force on another equal amount of force exerted back on it. And last, demonstrate how body responds to change in motion. Okay, in your lower grades, you know already what is force. Okay, let's review what is force. Okay, force is a push or pull upon an object resulting the objects with one another object. So that is the force. Okay, what is balance force? Balance force are two forces acting in opposite direction on an object, the equal in size. Anytime there is a balance force on an object, the object stays still or continues to move at the same speed and in the same direction. So it means that the balance force, if ang isa ka bagay nag-stay sa isa lang ka lugar, so that is balance. Then, if for example, ang isa ka salakyan nag-move in the same speed, in the same direction, that is also balance. Next is unbalanced force. So what is unbalanced force? When two forces acting on an object are not equal in size, so that is the unbalanced force. So here's the video that shows the balanced force and unbalanced force.
Take a look at what happens when forces are unbalanced. Welcome to Moo Math and Science in balanced and unbalanced forces. Newton's first law of motion states that an object at rest stays at rest, and an object in motion stays in motion at the same speed and in the same direction unless acted upon by an unbalanced force. But how are balanced and unbalanced forces different? Balanced forces will cause no change in the speed of an object. Balanced forces acting on an object in opposite directions and in equal strength, as shown in the arrows below, do not cause a change in the speed of a moving object. Objects that are not moving will not start moving if acted on by balanced forces. Remember, forces have a magnitude and a direction. Unbalanced forces are not equal, and they cause the motion of an object to change. When two unbalanced forces are exerted in opposite directions, their combined force is equal to the difference between the two forces. The magnitude and direction of the net force affects the resulting motion. This combined force is exerted in the direction of the larger force. Let's take a look at some real-world examples. The forces acting on the red pull balls are balanced. The downward force of gravity is equal to the resistance force of the pull table. When the white ball strikes the red balls, the forces are now unbalanced and they move in the direction of the force. The forces are balanced on the weights. The downward force of gravity is equal to the resistance force of the yellow rack. The weights do not move. The weightlifter exerts an unbalanced force upward, and the weights move in that direction. The forces on the tennis balls are equal. They are not moving. When the tennis balls are struck by an unbalanced force, it causes them to move. The resistance force of the car is balanced with the downward force of gravity. The car jack exerts an unbalanced force on the car upward, and the car moves in that direction. The car is at rest, and all forces are balanced. When the car that is moving strikes the car at rest, then the forces now are unbalanced, and the car moves in the direction of this force.
Okay, our main topic is about the three laws of motion. The first law of motion is the law of inertia. So the law of inertia states that an object are at rest, stay at rest, and an object in motion will continue to move at constant velocity, constant speed in straight line, unless it is acted upon by the net force. So a net force, it is a sum of all forces acting on an object. So law of inertia, it means that an object continued to be at rest if it was at rest, and moving if it was moving, if no unbalanced force are acting on it. So the property of objects when it opposes changes in motion, that's what we call the inertia. So consider the following situation in which the net force acting on the object is zero. So if an object is not moving, the speed and direction are zero. It means that all forces acting on it are balanced. The net force become also a zero. Then an object that is moving at constant velocity has the same speed and it is heading in the same direction. The acceleration is also zero. This also means that the forces acting on this object are balanced, and the net force is zero. So the law of inertia, objects do not accelerate on their own. Instead, a net external force has to be imposed to them to oppose the tendency of resistance so that the object will move or accelerate. So next is the mass as measure of inertia. So inertia is a property that is possessed by any material so long as it has mass. So the more massive the object is, the more inertia there is. So it means kung dako ang object, dako man ang iya nga inertia. So if an object has great mass, it has a great tendency to resist the changes imposed to it. So for example, it is comparing a truck and a car that are moving at the same velocity. So if these vehicles either change their speed or direction, you will see that the truck exhibit more inertia in effort to expended to change its speed or direction. So kay mas mabugat ang truck kisa sa car, so mas madamo gid nga effort ang iya ihatag para mag-change ang iya nga speed or ang iya nga direction. So it is hard to speed up or slow down a more massive object. So that is correct. Pag dako ang object, mas mahinay siya mag-change sang iya nga motion. It's because mas dako ang iya nga inertia. So mass is the amount of matter an object contains, and weight is the force acting on the matter when acted upon the force gravity. So here's the formula of weight. Sorry for the wrong spelling of weight. So here's W is equals to mg, or weight is equals to mass multiplied by the gravity. So in a common unit used for measurement of the amount of matter is called kilograms. Acceleration that is because of gravity at sea level has valued and a unit of 9.8 meter per second squared. So when the two quantities are multiplied, the combined unit become kilogram meter per second squared, or collective known as a Newton unit. So the following table summarize this. So the unit of weight is kilogram meter per second squared, or Newton. Then sa mass, that is kilogram. Then sa earth gravity, 9.8 meter per second squared. So here's the example. So if the pull of gravity changes, its weight also changes. So but the mass of the same object does not. Example, the gravity on the moon is only 1/6 as strong as on Earth, as strong as on the Earth. So if a person has a mass of 50 kg, how much will weight on Earth and the moon? Will the mass of the person change when it goes to the moon? So the following solution explain. So here's the solution. So on Earth, so mass is equals to, let's substitute, 50 kg. So the gravity on Earth is 9.8 meter per second squared. So the formula of weight is equals to mass times gravity. So let's substitute 50 kilogram times 9.8 meter per second squared is equals 490 kilogram meter per squared or 400 Newton. Take note that the 1 Newton is equivalent of 1 kg meter per second squared. But on the moon, mass is equals 50 kg. Then the gravity on the moon is 1/6. Then multiplied by the gravity on Earth, 9.8 meter per second squared is equals to 1.63 meter per second squared. So the formula is weight is equals to mass times gravity. So let's substitute the 50 kg times 1.63 meter per second is equals to 8167 kilogram meter per second or 81.67 Newton. So that is the example. The next law is the law of acceleration. So we do not see objects that do not change their state of motion. So when vehicles move, they eventually stop when they reach their destination. A stationary object can be moved when a force is applied to it that overcomes its state of being at rest. A flying balloon will soon fall back to the ground. Motion keeps on changing because of the action of the force applied. So forces of varying types, when they are imposed and cause an unbalanced state to an object, always result in acceleration. So the second law is the law of acceleration, states that the law of acceleration, when there is a net force applied on the object will accelerate with the same direction as the net force applied. Its acceleration is directly proportional to the net force but inversely proportional to its mass. So acceleration is directly proportional to net force, and both should have the same direction. And acceleration is inversely proportional to inertia or the mass. So unbalanced forces result in net force that leads to acceleration. So here's the mathematical equation of acceleration. So the direction of its acceleration is the same as direction of the net force applied on it. In mathematical equation, net force is equals to mass multiplied by acceleration. So F net is the net force applied, M is the mass of object, and A is the acceleration. So from this equation, the following are the conversion of force. So remember, that 1 Newton is equivalent of 1 kg per second. And 1 dyne is equals to 1 gram centimeter per second squared. Per second squared. So here's the formula of acceleration. A is equals net force over mass. Next is the law of interaction. So the law of interaction states that every action force there is an equal but opposite reaction force. So interaction occurs in the two different bodies. The action and the reaction forces are equal in magnitude and in opposite direction, but they do not cancel each other because the forces are acting on two different objects. So let's say, for example, the interaction of the feet and the ground. So when the feet touch the ground, it exerts a force on the ground because of the body's weight. However, there must also be a force that prevents the feet from going straight down. So the feet remain on the ground, so that this means that there should be an upward force equal to the downward force that maintains this stability. So this means the ground also exerts a force towards the feet. So in Newton's third law of motion, a pair of force called the action force and the reaction force. It is present in interacting objects. So when the two objects interact, there is a reaction force that is equal in magnitude but in the opposite direction. So the third law of motion is commonly stated that for every action there is an equal and opposite reaction. And here's the following example of action-reaction pair of forces. Number 1, bracket pushing on the gas pushing on the racket, tires pushing on the ground pushing on the tires, glove pushing on the face pushing on the gloves, bird hitting the windshield of a car, windshield hitting the bird. So in this given example, the force pair regardless of which is the action and the reaction force, it is always equal and directed in the opposite direction. Notice that these forces are acting on different objects. So even if the amount of force are equal and in opposite direction, this does not mean they can be cancelled. For forces to be balanced and cancelable, they have to be directed in the same object. That is why acceleration still happens. So in a single interaction between two objects, forces are equal in magnitude and are in the other direction with the same line of action. So when these objects show acceleration, it means that other forces are acting on that accelerating object. So the second law governs this, the relationship of the net force, mass, and acceleration. Case of the bird hitting in windshield, it does not stop the movement of the car just because a bird hits the windshield. Instead, it is the bird that stops and the other proceeds. The change in motion of the bird is greater than the car because it has smaller mass. So a certain amount of force divided by the smaller mass produces a high acceleration. The changes in motion are very noticeable if the mass difference of the object is very large. So the third law of motion states that for every action force, there is a reaction force equal in strength and opposite in direction. Okay, let's practice the problem. So fill in the missing quantities in each item. Note that if there are two forces acting on the body, you need to find the net force first. So let's say, for example, find the acceleration. So I have here the solution on how to solve. Let's find the acceleration, or the required is acceleration. Then force is 220 Newton. The mass is 100 kg. So the formula of acceleration is A is equals to if net or net force over mass. Okay, let's substitute. A is equals to 200 Newton over 100 kg. Then let's divide the 220 to 110 is equals to Newton over kg. Okay. For the unit of acceleration is meter per seconds. Let's convert to, then 1 Newton is equals 1 kg meter per second squared. Then let's cancel this kg. So the final answer is 2 ms a meter per second squared. So this is the final answer. Okay, the next problem is the 2,000 kilogram train moving at constant speed is pushed in the opposite direction. If the train decelerated at the rate of 10 meter per second squared, how much the force was exerted on the train? So I have here also the solution. Let's find the force, or the required is force. The mass is equals 200 kilogram. Then the acceleration is 10 meter per second. Okay, the formula of force is F is equals to mass times acceleration. Okay, let's substitute. F is equals mass is 200 kg times 10 meter per second squared. Okay, let's multiplied by the 2,000 to 10. 2,000, that is 20,000 kilogram meter per second squared. So this is the answer, the 20,000 kilogram meter per second squared. And also the force is 20,000 Newton. Always remember that the 1 Newton is equals to 1 kilogram meter per second squared. Okay, that's it. Okay, maaari nyo nang sagutan ng inyong mga activity. So, take the written assignments. From letter A to C. Then, connect and apply to the real world. And connect and explore the cyber world. Then, answer the ponder and wonder. Okay, see you next week for another topic. Bye!